thank you very much for joining us. We've got a different product we're going to showcase for you today. So we wanted to make it something special because that's something really special underneath there. All a brand new range. Wherever you see S6 now, they're all brand new. Some of them have been around for a little bit, but we've changed and upgraded. Okay, so I don't know how many people actually, we've done a lot of training sessions and how many people have been in it. And we normally have this startup, especially on product launches and whatever. So Solis was founded 20 years ago this year by Jimmy Wang. It's actually Yiming, but it's affectionately known by everybody just as Jimmy, in 2005. And obviously I'm not going to spend an hour going through all the milestones, but we've had many milestones over these 20 years. From the initial start of making little 5 and 10 kilowatt hybrid or wind turbine inverters to where we are today. And I mean, there's still some of those wind turbine inverters in South Africa that are still running that was built a very long time ago. So it's a big milestone for us this year, and we're celebrating with a bunch of new products. So we've introduced probably about 4 new product ranges this year in different aspects of the business, in hybrid and off-grid. Although small off-grid, we basically incorporated off-grid in all the other products now. And then a bunch of new C&I grid tie inverters, as well as the whole range actually from like 5 kilowatt 3-phase all the way through has been reworked and revamped. You know, it's for a business like ours, we have to keep up with the times. We have to keep up with technology advancements. For instance, solar modules. They don't wait for anybody. They just say, well, we're making this now, and now it's got 18 amps of current. Oh, you can't use it with this because you're going to blow it up. So all our products have now basically been reworked to cope with the latest and the greatest in the panel world. As you can see also with this product, we have now 21 amp string inputs on all our products. So you can go 800 watt, you can go bifacial and whatever. We're fully certified for that. So a lot of changes have been made to product to accommodate all the challenges the market is throwing at us. So I'm not going to bore you with too much of this stuff. So there's a whole lot of more stuff. So basically right now, as we are standing here today, Solis is the 3rd biggest manufacturer of inverters in the world, globally. I just want to show you some things. When I started the company, I'm in my 7th year now, this year, now, actually from July. Went into my 7th year with the business in South Africa. And when I started here, the R&D team was like 150. Right? Just to give you an idea. The global employees was, I don't even think it was like 800 or something. So we're 500, over 5,000 now. R&D team is expanded to 1,000 plus. Our global shipments exceeded 120 gigawatts. And our manufacturing capacity as it stands today, after the opening of the 2nd new factory, is at 80 gigawatts a year. This is what we can push through the factory. So if you want to work out how many inverters it takes, 80 million divided by 5,000, like a 5 kilowatt inverter, it's a lot. Okay, we'll keep you busy for a while. Currently, our total assets sits about $2.9 billion US, and we're in the process of building a 3rd factory. So the 3rd factory will be finished in a few months, and that will push our manufacturing capacity to about 120 gigawatts, right, which is a lot. It's really a lot. It doesn't sound like a lot, but how many solar farms are that? Like, and all of that in 1 year. So we can do that in 1 year. Okay, you can just all the business stuff, you know, graphs and things. So just the significance of this slide actually lies in here. Just to give you an idea of what happened. I mean, everybody knows what happened right through here. Right? COVID. So even through the COVID years, and the world was at lockdown, the business never stopped. I mean, I was with Solis at the time, we never stopped working for 1 day. Right? We were still busy, people were still working, and we managed to grow through this quite significantly. So that has to tell you something about the business. So it's fantastic. Okay, so we are currently considered worldwide the #1 inverter in home, and again, sorry, that is for grid tie inverters, just to be clear. Bloomberg, we have received recently a new rating from Bloomberg as a Tier 1 global supplier. And obviously, as I said, we are rated by Woods Mackenzie's top 3 inverter supplier globally. Okay, we have a 20-year history, top PV brands. I mean, we've won EUPD top PV brands for the last, I think, 11 years in a row. So, which is quite significant. I think a couple of years ago, we were actually here in Cape Town on a little networking thing on this catamaran that goes out of the harbour here, and we actually received our first one, and next year we got the next one. Our assembly line on the new factory has been completely updated, so completely state-of-the-art, really fast. Anybody that comes from a process industry like I used to come from before my solar life, you know, you love watching stuff like this because it's just precision. In that factory, basically almost QC gets done as the components get placed. There's a camera that actually takes a picture, make sure it's right, make sure it's the right part number, make sure it's everything before the product actually moves on. But it happens at super fast speed. Okay, so just with that in mind, give you a little glimpse of what happens in there. The sound. Thank you. Quite impressive, right? It's actually fantastic to actually go there and see it. If, by the way, you guys ever find yourself near Ningbo in China or going to the Snake event and whatever, you are welcome to engage with us. If you are there, because all the time we're looking for, well, when people are there, they arrange tours. They will pick the guys up from Snake somewhere, take them to the factory, and then take them back again. So they love showing off that. So you're more than welcome to engage with us whenever you're out there, or you're in China, or you're in Ningbo, anywhere close where the factory is. You're more than welcome to take a tour there. And hopefully you can get a coffee in there as well. So one thing that's very important for us is basically servicing customers as well. You can have the best product in the world. If the service is not there, you're basically like dead in the water already before you even started. So we've invested a lot of time, a lot of effort in expanding not just technical support, but pre-sale support, product solutions. We've created all these teams all over the world to bring all that information together so we can actually provide a better service. So currently in South Africa, we actually keep our own stock here. We service the after-sales market with warranty services ourselves. We have a big warehouse in Johannesburg, and we ship all over the country. Pretty much, if the warranty is improved within 24 hours, generally, we ship it. And pretty much anywhere in South Africa, depending if you're in, well, if you're in like Springbok, it might take more than a day or 24 hours to get there because the truck's got to go via. But I mean, that's unfortunately out of our control. But generally, at the moment, as it stands, our first time response is in the region of about 21 minutes. And our case resolution, on average, sitting at about 49 hours, so 2 days and an hour. Right, and that's from the case started until we ship the inverter. Okay, after that, it's a little bit out of our control, but most of the direct big centers, we can ship, and it's generally overnight to any one of those. So we have a really dedicated team of guys and gal that look after these guys, and I think some of these guys might have already spoken to them. Some of those guys, I mean, Walter's now also going, he's for his 5th year now that he's entering. He started like 2 years after me. Jason is pretty new, 2 years now, but I mean, the people has been around for a bit. And it's they carry a wealth of experience with the product and in solution and providing solutions for the product. We've done a lot of work behind the scenes on a lot of these products just to make your lives a lot easier. From an installation perspective, from a service perspective, we've established a national service line. We'll share the contact details later on, both on a voice over IP system and a direct emailing service. And then we actually run a Saturday service from 8 till 3 on a Saturday now as well, because seemingly people don't have enough time in the week. I'm just kidding. Okay, so obviously we spend a lot of time on making sure that we conform to all the market norms, looking at our carbon footprint, supply chain management, product design, energy consumption, even down to things like the packaging of product. There's a lot of pressure throughout the world about looking at packaging and product packaging and what you use in product packaging, so there's this constant review of all those things going on. So it's way more than just getting an inverter to you, it's also the way it gets to you. That is a lot of responsibility on a business like ours. So, brings us the good stuff. Right, so today we will introduce to you our latest creation, like a little Frankenstein job. No, I'm kidding, it's not Frankenstein. It's put together really well. Which is the new hybrid inverter. And if I can ask on the net, please, come and join me here. And if you guys will bear with us a second as we can unveil to you our latest creation, the Solis 80 to 125 kilowatt hybrid inverter that we will be launching shortly here. It's pretty, eh? We want to put a bikini on there, but it's a little bit much. So basically in this product range, we will have 3 models, 80 kilowatt, 100 kilowatt, and 125 kilowatt. So I think right now in this particular range, and in this application, I think we probably have the biggest one, full hybrid system. So there's a launch time of November 2025. It's actually the actual production date will start in November. There will be a short product launch, about 250 pieces, starting within the next couple of weeks. Chairman, am I right? Next few weeks, huh? So at the moment, it's a case of getting components in stock, components, heat sinks, and all the wonderful things. There will be a release of 250 pieces globally, and then the full production will start in November this year. Okay, so we have a PCS charge and discharge function, PV generation, on-off grid, and genset switching, and the EMS management feature. Okay, the inverter obviously can be incorporated in battery packs, battery modules, So we boast a upgraded IP66 rating for this inverter. So all the previous ones were IP65, but because of the application of this, more outdoorsy, it's a more robust C&I system. We also have a C5 coating now on the outside, which is a higher grade of protection, especially coastal areas and things like that. And also mining and industrial need a special thing. So the traditional battery solution, as you see it, and with PCS systems, with renewable in there, is generally only an IP21 rating. Okay? So why IP66 is longevity of the product. Okay, you saw the little product video of the factory we showed earlier. Personally, I know, or what I know of, is that we're the only guys through a manufacturing process that actually coats a protective layer on our PC boards and components 3 times during the cycle of that manufacturing. Okay, as far as I know, nobody else does that. And again, people say, but why would you want to do that? So it lasts longer. Okay. Going through a cycle like that is to get a product to get to a 20-year life cycle design. Okay, so the Bloomberg rating you saw earlier, that covers that. So they actually certify the design life of the inverter as 20 years. Right? How you handle it, and if you drive a forklift into it, sorry, that's going to influence the whole thing. Right? But so IP66, the whole inverter. So you can put this outside, no problem. Just, you want a little canopy over it. Why do we want to do that? Simple. You want to try and reduce the direct heat on this thing. Right? To give you an idea, this is a 110 kilowatt grid tie inverter. That at full power generates like 3.3 kilowatts of heat. Okay, now imagine 10 of those in a room. It's quite a nice sauna. Right? So it gets really hot. So we have to manage the heat as best as we can. So in any product, if you want to manage the heat and keep an IP rating like that, it takes a lot of research and design and sorting out the heat sinks. Because the only way in an IP-rated product that you can get rid of the heat is through the heat sink. Right? The back. So the heat sink absorbs the heat, discharges it, and so you carry on. Whereas with an IP21, it means there's no IP rating, so it's not enclosed. Right? So you have environmental factors, you have dust getting in there, you have humidity getting in there. There's a lot of stuff that can get in, and little bugs, and millipedes and everything. And tomorrow the thing blows up and you don't know why, and it's because of the ingress that has gotten into that product. Okay? So to make sure that we keep it, and now I'm just going to say this, this has also been a little bit redone apart from here. Right? But a lot of this, we've taken a lot of the small glands out. Okay? Because what we've seen in the residential area, all the guys take all the glands out and they bring all these little widespread tubing pipes in, And immediately when you take the gland out, what do? You ruin the IP rating of the product. It's gone. It's as simple as that. Because any product that heats up, when it works really hard, tonight everybody goes to sleep, factory shuts down, and then what happens to the inverter? It slows down. It doesn't have that bigger load on it. And if there's air inside, what happens to that air? It condensates. And then it sits on the board, and then tomorrow, guys come and they start up a bunch of things, and then it's action, and the inverter blows up, and you say, oh, you made another crappy inverter. It's not that. Okay? There's moisture in the system. And electricity and moisture don't like each other. Okay? It's like a brother and a sister. They just can't get along. Okay? But that's why it's important. We have to make sure that the ingress is protected all the time. Right? We've added a brand new set of connectors here at the bottom. So this particularly, this is for one of the phases. Okay? Quite a simple thing. But again, it is only ingress protected if it's installed proper. So if you put this in, you don't tighten the compression gland here, there's no IP rating anymore. Right? It's a simple thing. I don't know if anybody ever worked in hazardous area field. You know, I built a lot of boxes years ago for places like Shell and Engen down here, and Sasol and Natref and Petro SA. And those boxes have to be tested. And you have to draw a vacuum from them, and they have to pass a very rigorous test. And then even so, once it's installed, some master installation electrician has got to go there and certify that that has been installed in accordance with the IP ratings that is required for that installation. Okay? If the gland not tightened or whatever, it fails. So it's the same here. We have to make sure that when we install it, just install it properly. It's not a big ask, but if you want it to last, just do it properly. We can't be on every site and say, oh, you haven't done, you haven't. But when it blows up, we will check it first. Who's got a pipe in there? Okay, so basically we call this a smart string hybrid solution and separate place battery in a 4 in life. So we have separated this and this, because a lot of the stuff, where there's a PCS in the system, that's all. The PCSs and the batteries and everything lives in the same container space or enclosure space, thus generating even more amounts of heat within that enclosed space. Right, so what does that do? So the more heat is in the space, the less efficient any system becomes. You know? Batteries don't like heat, too much of it, and they certainly don't like cold. I mean, we all know that. So we've taken it out to exclude that heat, and then also this doesn't influence, well, the heat from the inverter doesn't influence the batteries. So also wide voltage range. So we upped the voltage range from our 50 kilowatt product, which was around about 800 or so, 850 volts. So on this inverter now, the battery voltage can go up to 950 volts. Okay. So you can do some calculations there, 950 volts, and we have 2 charge ports down here. Each one of those charge ports can handle 100 amps. Okay, so you can do a little bit of math. So it's quite a high charge and discharge capacity. So if we look at one of the topologies, so this inverter can do a lot of things, right? So if we look at all of this, we have the PV, we have the battery, we have the backup load, we have grid-fired loads, which is your non-essential loads, right? There's like stuff that you can do without when the power goes out. Then we have smart meter or CT, which is the system one, and then we have the utility meter and the utility side. Generator or smart load or PV inverter. So what do we mean by that? The inverter is equipped with what we call a smart port. Okay, so that smart port has 3 functions. 1, you can connect the generator to it. 2, you can put a smart load on it, which I'll explain in a minute. And 3, you can AC couple a PV grid-tie inverter to it. Okay? So when a generator is on it, because a lot of sites where the guys go in and they install a system, let's say they build a system and they put 4 in parallel, there's 500 kilowatts, but the generator might only be 300 on site. Okay, so the guys say, well, yeah, no, you know, if this thing starts drawing power, it's going to kill my generator. Okay, we thought of that. So the generator port or the smart port can be set. So you can tell it, I've got a 300 kVA generator on site, but when you draw power for it to help charge batteries or whatever, you can only take 200 or 250 kilowatts from it. Okay, so it will always control the amount of power that comes into the system through that port. Okay, and then sometimes you have a really big battery bank or an existing PV site already where you're adding this to. So we'll get to the PV capacity of the product just now, but the smart port can also double up as an AC coupled port. So what do we mean by that? I don't know. Everybody knows what AC coupled means? I think Most of the people deal with this do, but just for interest sake. So when you couple AC, a grid-tied inverter to the AC couple port, the inverter will react to frequency shifting when the system goes into backup. Okay, so it will be controlled by a shifting frequency. Normally it starts at 50.5 hertz, and at that point it will ask for maximum power from the grid-tied system, or it will then slowly progress up to 52.74 hertz, and at that point it will basically tell the system, I don't need any more PV power from you. So it will slow it down, right? Completely automatic, nobody needs to touch it, and then generally for safety it's got to cut off all this frequency around 53 hertz, which will just completely cut off. But that will just happen, and the nice thing about that can be done with multiple different inverters. So it doesn't just have to be a Solis inverter, because your frequency shifting, as long as that product is capable of frequency shifting, you can use it. Okay? And then the smart load. So this is, I've affectionately come up with a name for this, is the non-essential essential loads. Okay, so this is a nice to haves. So in a residential, if I can sum it up with a residential, so in the garden, you know, you got all your essential backup stuff and the kids' lights and the fridge and TV and the DSTV code and the internet and everything else. But in the garden, the front garden, you've got a beautiful, nice, you know, fish pond with black lights and whatever. So when load shedding is there, the neighbors will say, oh, he's got power, look at the fish pond, it's beautiful. Right? But now the oak's not there, it's sitting in Mauritius, drinking pina coladas because it's winter in South Africa and the panels are full of snow and all that type of thing. And now he's got that load connected to his smart port. So the smart port can be set to dump that load. Okay? So you can say, when my batteries reach 50%, the fish can go to sleep now, they don't need light anymore. They've got an oxygen switch off the pump, all that type of thing. So it will switch that off to reserve or preserve more battery life. And then you will have a re-switch on SOC setting where once the battery is recharged to a certain point, say, okay, the fish can now wake up, you can have some more light and oxygen. Okay, and it will allow that port to come back to life. Then obviously through that we have a data logger that goes in the bottom. Yeah. Stop this in the pocket before it falls off. Anyway, the data logger is supplied with the product. So it actually allows you two types of connection. One is through an Ethernet connection, so it's a direct RJ45 plug-in. The second is through a Wi-Fi connection. So it's a two-in-one device, and there's a third device, so really remote sites where you don't have Ethernet or you don't have Wi-Fi, but you potentially have maybe a cell tower, and we also will be offering shortly a GPRS monitoring device, not just for this product, for everyone, because that same device at the bottom there basically fits all the new products. So there's a bunch of scenarios here now, so if you're going to bear with me for this. So the first and most prominent of any of the applications, whether it's residential, commercial, always centers around self-use, right? And it's where we are sitting now in the current market. So a little while ago, we were dumped in load shedding, whatever, and everybody was using fully developed, very smart hybrid inverters purely as a backup system, right? So they never understood what the whole design about this is. Or maybe they did, but just not applied. So a lot of our training now goes to teach installers and customers and end users, where we do get to engage with them about how to use the inverter properly. And it's not to say anybody is dumb or stupid or anything like that, but people don't look at all the features of the building and say, how can I implement this in my building, in my house, in everything, so that I can get the most out of the system? Okay, and really save power. Okay, that's what self-use is all about, is saving power as fast as possible. Right, so in self-use, The grid load, this is the system, the parts of the system which is not on the backup board, right? So that sits between your utility supply and the inverter. Then you've got your backup load, you've got your battery and your PV and your monitoring device. Okay? So in this solution, so power from the whole system can move throughout the whole system. If you're in Cape Town and you're lucky enough and you can export some power, it can actually go back to the grid as well. Okay, you guys are really spoiled down here. Other guys are still battling to get that done. But I mean, you can really use the system. You can set time of use functions. Okay. You have 12 settings for that. Okay. 6 discharge functions. Each can be related to also SOC, so the state of charge of the battery. Right, so you've got all these fantastic controlling bits and pieces of equipment that's just not getting used. I'll give you a scenario, a simple residential one. Some time ago, we did a little system for a customer as a little test site, and we were playing around with his system, and he agreed to that. So he went for about 4,500 Rand a month on a prepaid system, now buying maybe 400 to 600 every 2 months. And it's not a massively big system. Got 2 5 kilowatt hour batteries, 16 panel on the roof, and 8 kilowatt inverter. That's it. And that is just from applying the system correctly. I mean, he can expand. His batteries are fully charged in the morning by 9 o'clock, 10 o'clock done. Right? He can add another 4 batteries, it won't even be a problem. But the point is, by using it correctly, it's an immediate saving. Without trying to make the hard sell, what if load shedding comes back? What if they steal the cable? In the meantime, the price of electricity is just going, right? Uncontrolled, really. I mean, now July was about 12, 14%. It's crazy. But the use of all the power within the system to make you get the most out of it is our most common use of it. The most common setting mode for anyone who does self-use. And that even applies if the whole system runs through the inverters. Okay, so you also have the option, and in this mode, like setting first, you can set the priority. So if we just go back to the previous one, let's just look at the mode priorities. And I think there's a slide later on that comes with it, but we can skip over that one. So the priority in self-use mode is that the load takes first priority, right? The backup load comes out here. That is the first priority, always. If it's PV available, the first place it's going to go is to that load. The second place it's going to go is to the battery. Okay, so first it's going to go here. Any residue is going to go here. And any residue after that will come back into the grid system or the non-essential loads of the system. Or then, in fact, selling back to the grid. Okay, because we can also control that amount. So a lot of places you might install this and the council comes back to you and says, yeah, okay, that's very borderline. We're going to restrict the amount of power you send back or you may sell back to the grid. Okay? Because of the infrastructure that's available or existing, and then you can set it. And out of this, at no point in time do we want to, at any time, send more than 10 kilowatt an hour back to the grid. Okay? This is the function and the setting that you can just set. Okay? So it makes provision for all of those things. So in excess electricity sold first, the backup load port is still priority number 1. Okay? But the second priority now changes to power coming this way. And the battery becomes the third priority. Okay, in other words, you're not going to use as much battery, but you want to sell the PV power back to the grid. And if you're lucky enough, you can have a big battery bank, and if it's charged full, tonight you can discharge that power, and it will send it back to the grid. Okay, so energy arbitraging. In Belgium right now, we have an API integrated from the local council that talks to the inverter every day. They publish 2 rates every day at different times, different rates for cheaper power and more expensive power. So as soon as they publish the rates, the inverter recognizes, oh, okay, the power is really cheap between 5 o'clock and 7 o'clock this morning. So I'm going to take some of that power and I'm going to charge the battery with it. And then it's going to become really expensive between 6 and 9 o'clock tonight. And say, okay, we're going to use that same power and we're going to sell it back to the grid at a more expensive price. Right? And because of the API integration with that country and the municipality, that all happens automatically. Nobody even touches the inverter to do that. Okay, it automatically adjusts to that every single day. So there's a lot of stuff that's capable as long as the infrastructure is there to do it. I know it's not like, yeah, okay, it's going to take a while. Okay, and then obviously the third one is obviously zero export to the grid. So the export manager, the smart meter that is on the other end, basically helps the system to stop export from the grid, and you manage and you keep all that power within your own system where you cannot export. Also, normally, especially on 3-phase systems, we have a problem of unbalanced loads a lot of the time. And we get a lot of electricians go to the site and say, add a plug, add a machine with a red phase. Can you add the fan or the air conditioner? Yep, red phase. Until that bus bar is full, and then it goes to the white phase, and then eventually there's nothing on a blue phase. Okay, we've all seen it, we all know it, and that causes a lot of problems for inverter systems, especially 3-phase equipment like a 3-phase grid tie. I mean, we've got a regulation that says the inverter must supply equal power to the grid. This, however, will be able to handle unbalanced loads 100% on grid and backup port side. Okay, so let's just clarify the 100%. Okay, because we had this question the other night. Okay, the inverter rating is 125 kilowatts. So each phase is like 41 point something kilowatts. Right? So that is 100% of that phase. You cannot go take from phase 2 and say, that red bus bar is full, here's some more power from the white one. Okay. In other words, basically what we're saying is phase 1 on the grid side can sit at 41 kilowatts, phase 2 can sit at 5, and phase 3 can sit at 0, and it will just handle it. And exactly the same applies to the backup board. Okay, which is quite a significant addition to the system. So, peak shaving. Has anybody installed anything for peak shaving? I just want to see a show of hands. Okay, it's not that big yet, but it's getting more prominent because people are getting penalized for the amount of power they pull from the grid at any one time. I'm not sure lately here, but we've seen it now. What happens a lot of time in other regions is Eskom used to charge the guys monthly for kVA demand and whatever the highest kVA peak demand. Now they do it, if you go over it once, they just charge you for the year. Right? So the poor guy made a mistake once of running stuff at the wrong time, and then now he's got to pay for the year. When we've seen so many of these guys stuck with the bill, where the kVA demand rate or that charge that they get charged and pay is way more than the actual kilowatt hours that they're consuming. Right? So it's a big problem. So the inverter's got a system that we call, or commonly referred to as peak shaving. So you will set a setting in the inverter to say, we do not want to exceed this amount of power coming in from the grid. So that meter sitting on that side is going to say, okay, we'll check it. You know, we'll put a guard there, make sure. Then as soon as that power creeps up to that level, the management system kicks over and says, hang on, we can't go over that. Right? And it will start discharging from the battery to keep that load within that spec. We actually have a pretty good peak shaving example running at a hotel in Port Elizabeth. There's 350 kilowatts in there, not quite this one, but the operation is still the same. The whole place runs through it, and that's controlled at 75 kilowatts input from the grid. Okay, exactly. It doesn't go over, and it's always controlled right. And in the event of a backup or an electricity problem, they don't even know they have a problem because the system just carries on working. But it's a perfect example of that, and it works really well. That hotel there, the minute they go over 75 kilowatt, their kilowatt hour price doubled immediately. I've got a colleague, my counterpart in Belgium, in a residential. They are limited to 3.5 kilowatts from the grid as an import. Okay, so if it goes over them peak, or they go over that, if you want to do the math, there's like €3.60 a kilowatt. It's crazy. It's cheaper to run a generator then. Okay, I don't know about the price of fuel in Europe, but anyway, it makes a big difference. So it's a very, very strong attribute. And then obviously arbitraging, and that you will use all the time settings for again, where you can export, not export, pull in power, export power. So arbitrage is very strong. I mean, we sell a gazillion inverters in Europe. And 99% of all those inverters sold, the backup ports are not even connected. But they work for energy arbitraging every day of their life. Energy in, energy out, energy in, energy out, and that's all they do with it. We have another product in those markets, mostly for residential. It's just called a little battery inverter, so it's got no PV input and whatever. All it does is just arbitraging to the batteries and back. A very specific product for that market. We can't work here. So time of use. These are basically VPAP EMS companies that's already integrated via the API, just in other regions. South Africa's not there. Don't know why. Okay, but third-party EMS systems obviously control that system and giving it the information that it needs. It's been integrated through the API, and then it will use the power. I mean, it's like now in Cape Town, I think you've got the DMP3 protocol for everything over 100 kilowatt, right? And the reason why they want to use it all is to combat grid instability and all that. They want to have control over that inverter. In the UK, they call it DRM, so demand response management. The device is we've got a little port on most of these that's got a DRM port, and that will control the inverter power from the council. It's like thinking back in the older days, the old ripple relays for the geyser, same thing. It's just on inverter, the council can then say, all right, okay, we've got an overvoltage situation and grid's a bit unstable and whatever. We've got to take some of the injection from the PV systems out of the system. Right? Because they do a lot of PV injection. And then what they do is they send a signal to the DRM and say, listen, we want all the inverters to slow down to 50%. Okay? There's like 5 settings in it, 0, 25, 50, 75, and 100%. And they will control it that way. So the API pretty much does the same thing, but it interfaces and it will draw power from the grid, and that will happen automatically if that's integrated properly. So time of use, we spoke about that briefly earlier, just in practice what we look at. So we've got a time slot, 6 charge time slots, and 6 discharge time slots, and that's all 12 time slots within a 24-hour window, okay, that you can set. And with that, it's also coupled a time slot with regards to your SOC of the battery. So let's say, for instance, you know that in the morning, kids get up, they get hungry, the kettle goes on, people shower, the fridge goes open 6,000 times if you've got teenagers between 6 and 5 past 6. So the fridge is on all the time. So you have a very high energy demand early in the morning because everybody's getting ready to go to school. You can then set that, say, listen, every morning, because the alarm goes off at 5 o'clock, till 7 o'clock when everybody departs for school and work, I want to use the battery to supplement my load from the grid, because it's also normally a peak charge time for your cost of electricity. So then you can set that. But let's say your battery is at 100%. When it starts that, you can then set the SOC against that time. So let's say you set that at 90%. Say for whatever reason you are charging more or using more energy, it's not going to last you through your 2 hours, but you're going to hit the 90% after 1 hour. Remember, 90% is your control point, right? You being the boss there. And so you can use all of that till you get to 90%. After that, you can stop. No more discharging, right? And you can set that for every time slot, whether you're charging or discharging. There's an SOC associated setting for that. So you have 12 of those through a 24-hour time slot. So you've got a lot of flexibility. You can even set the discharge slot there for when the kids come home in the afternoon, at night when the house gets busy. So you've got a lot of flexibility in the system for that. Okay, dynamic tariff arbitrage is what we spoke about earlier. I'm not going to take too much time on that. AC coupling, just also, all I'm saying here in this slide is you can actually retrofit this product to an existing plant where there's already grid tie inverters. And we've basically covered that rule. So again, all I'm saying is smart gen, inverter port connecting, generator when utility power outage. So any one of those three things can work together to make sure that you all have energy security within your system. So we have an automatic generator start function, again working on associated SOC with the battery. So it's a very simple thing. There's a relay inside the inverter that you just normally wire from 12 volt of your battery through the relay, and it goes to the gen controller digital input port. Okay, and that's normally or would be programmed as a retained input. So as soon as the gen controller sends that input coming in, it will start the generator. It means that the inverter is saying, we've reached a certain SOC now, and I want you to help charge the batteries back up. Because it's the middle of the night, or it's snowing in Cape Town, and we're not going to get any PV power soon, but I need to up the SOC of my batteries a bit. And normally you're not going to run that function to charge the batteries at 100%. It's purely to assist them for when you can have PV assist charging again. Okay? And then also, when it gets the exit set point, it will open a relay and the generator will see that as a signal to shut down. Okay? Again, that can happen automatically if you've got the controller. On the residential systems, generally those ones don't have those controllers, so you're the starting signal and the shutting down signal. Again, smart load management, we spoke about that earlier. That's all through the smart port. And then battery reserve. So when you spoke about the self-use scenario earlier, a lot of people are concerned. So we're using a lot of energy from the battery to the battery, and we're doing all these wonderful things, and we're load managing everything, and the time of use discharging. At the end of the day, you still need to protect. We still have an unstable grid. Load shedding can come back anytime. We've seen that 100 times where you just enter into an outage. So you still want to make sure you have a reserved tally available for when that happens. Okay? So the reserve SOC setting in the system will stop any discharge function, whether it is timed or not through the time of use. But when it gets to that reserved SOC function, it will override all of those. Okay? So that you have that energy security stored in your battery for when those outages do come. Right? So that's like a control point. Right? And all those things, all the time of use and the SOC settings, those are all control points that you carefully work out and say, I want this, I want this, I want this, I want this, and you telling this machine, this is how I want you to operate. And it gives you all those tools to make it do so. So microgrid on the off-grid, so you also have the option of running the whole system completely off-grid, and then the generator on the grid side port, okay, as a mini grid. These are standard throughout all the products. basically. The only thing is that sometimes this machine doesn't know when a generator is on. Okay, because as far as the inverter is concerned, it sees power from the grid, regardless of the source. Right? And the inverter regards the grid as infinite power. It just can take as much as it wants. There's a signal that you need to just get from the generator. It comes in here, it's like normally, it's like a 5-volt digital signal. And that once the inverter receives that, it will know that the generator is now running. Okay? Because also the thing is, once the generator runs, this kind of like turns into wanting to export power to the grid because it thinks it's grid. Okay? So we can't allow that to happen. You can't export back onto the grid. So we have a bunch of settings in there for you that allows you to set spinning reserve of the generator and all those wonderful functions to protect the generator. It is, again, exactly the same as in any one of these other things. Okay, so we were talking about the working mode configuration and the priorities. So everywhere where you see a 1 within the system, it is priority. So load priority, and in an off-grid scenario, everything is priority. Right? All the systems is available, PV is available, batteries available, the backup load is available, and the power flows freely between any one of those sources. But in self-use, backup load, battery, grid. In selling first, load, grid, battery. Okay, make sense? And off-grid, obviously, everything just works. Okay, so if we look at some of the unique advantages of the product, we spoke about a lot of stuff now. So this particular inverter will support 200% AC to DC ratio. Okay, it basically means that a 125 kilowatt inverter can be populated with up to 250 kilowatts worth of PV power. Okay, so it basically means that if you're running 100 kilowatt on your backup port here, for instance, you can still be taking 100 kilowatt to your battery at the same time. Or you could be charging the battery, let's say your backup ports are like really low. At that point in time, you could be charging your battery and sending 100 kilowatts back to the grid if you are selling back to the grid. Okay? So to give you an idea, this inverter boasts the same amount of MPPTs as that. So it's 10 MPPTs with 20 strings going in at 21 amps a string. So 42 amps per MPPT. Okay, with 1,000 volt open circuit voltage on the PV side. So it's quite powerful. Okay, we outclass pretty much everybody when it comes to DC to AC ratios throughout the product range. Right, even our 50 kilowatts also, 200% AC to DC ratio. So a 50 kilowatt inverter can take 100 kilowatts worth of PV with exactly the same functions and features. So as I've mentioned now, all the strings are 21 amps, and that's load amps, not short circuit, right? Short circuit's a bit higher. But the load amps are 21 amps. Compatible with 100, from 100 to 314 amp hour battery systems. Packs. Okay, supports a discharge and charge current up to 200 amps. So there's 2 ports, each port at 100 amps each, and the voltage up to, I think, about 950 volts on the battery bank, which is quite high. All right? So lots of power can be had. 160% overload for 200 milliseconds. There's a bunch of other ones and whatever. It actually goes to like 120% for something like 6 seconds. I can't remember the exact number. I think it might come up. But it's a different overload function. There is a time limit attached. Okay, when it says 200, it doesn't mean 200 days, 200 weeks, 200 months. It's milliseconds or seconds. Our 8 kilowatt hybrid, for instance, can take 200% for 10 seconds. Right? So the two independent bay also run in the inverter two BMSs, two separate BMSs, which allows you to actually run two separate battery systems from two different manufacturers. Okay, so people say, but why? Why would you want to do that? Let's say you start off and you only put like 125 kilowatt, with 200 kilowatt battery bank on here, and it's only running through the one port, because you're going to upgrade later, right? You don't have all the money now. Your customer doesn't have all the money now, which is perfectly fine. But now, when it comes to that time when they want to upgrade, the guy that sold you those batteries is now sipping pina coladas in Mauritius. Made money, done, walks away. Then your customer says, now what does he do now? He's got to throw the old batteries away and get a whole new pack, but it doesn't have to be. So you can actually just add a second bank from another manufacturer. Okay? And you can run that on the second port. So you can have one that can give you 100 amps through that port, and another one can give you 100 amps through the other port. Okay, we actually run a system like that at the office. We've got two 50 kilowatts in parallel with 3 different battery manufacturers on between the two inverters. We've actually run them with different voltage levels as well. It works, but it's not advised. It just messes around a lot with the voltage systems and so on, but it does work. Okay. And then also we've added the 7-inch touchscreen. I think there's a picture in here, whatever. So on this screen, you can actually do the setup for the whole inverter through that screen as well, on site, to do the whole setup. But it also gives you an instant view of exactly where all the power in the system is going. Secondly, you'll have a Bluetooth connection, like with all the hybrid products. There is a Bluetooth connection for setup. And thirdly, you can do it through the monitoring portal. You can actually program all the functions through the monitoring portal. Okay? And you can also change those remotely. We were talking about the generator earlier, for instance, coupled to the SOC, stop and start on the SOC. You also have a forced start and stop function within the monitoring platform. So you could actually go and say, no, I need to charge my batteries a bit. Let's say you don't have the function connected, or it needs to be connected in the same way, but you could force start it. So I want you to charge now because I got a letter from Eskom saying the power's going out. And then once you're happy with the level, you can just switch it off again through the monitoring platform. In other words, what we're trying to say is, even if this is not connected to the internet and you get to site, you can still set it up. Okay, so basically just what we spoke now about the 200% AC to DC ratio. So you could get 125 kilowatt going there, 125 going there, and 250 coming from your PV system. Or 156, this is just a different configuration. Or if the batteries are full and you're not charging and you're selling back the power, obviously it can go back to the grid as well. Just remember, you cannot take 250 kilowatt out of the PV and send it back to the grid. Okay, there's a current limit on the grid connection side of the system, so you cannot send that back. But within the system, you can use the full 250 kilowatt capacity. If you are lucky enough so that you get a 1-to-1 ratio, which is probably never going to happen, we all know that. Also, the 21 amp, so it allows us bigger panels, which is going to allow you obviously a lot more power early in the morning and a lot more power down in the evening. So you get a way longer charge or PV cycle during the day. Some years ago, we had a customer with a utility project, and they were running huge battery banks as a system, and they needed as much power as possible from that system very early till very late. And there was the panel configuration of the ground mount system, but the east-west configuration. So for them, it was really important to start up early and carry on. They weren't so concerned about the massive bell curve at the top, the peak production. But it was more the length of production that they wanted out of the system. So in that system, they had 255 kilowatt grid tie inverters, and those were actually calculated as well, even at that time, to do a 260 6% AC to DC ratio. Okay? Gave them exactly what they wanted. A lot of power, more power for a longer period out of the day, although the curve might be a little bit flatter. So current limitations. So if you are using a system where you cannot take the full current as well from the system, the inverter applies, everybody must have heard it, it's called clipping. Okay, so it limits the power that's coming from the PV system. If you really push it too hard, then poof, right, you break the MPPTs. They work too hard and they break. So that's a very distinct advantage. I'll give you an idea. We had a customer some time ago. He runs his whole residential system on an off-grid system. He had another product in there, and he replaced them with two of ours on the same capacity, everything, except we have a different operating voltage for the PV input. So it starts up a lot lower, and we had a higher current rating for the one. But he didn't change the panels at that time. But just the earlier startup and later run during the day gave him about 3 kilowatt hours a day extra, which is a lot. It just doesn't sound a lot on a day, but over a week, over a month, over a year, it's a lot of power. And it's exactly the same thing applies right here. The bigger capacity you can start, you're going to start way early because you've got so much capacity in DC power available for you to use. Okay, so batteries. I think currently a lot of the batteries are like 280 amp hours, 260 amp hours. So we can now go up to 340 amp hour systems. It basically just delivered a lot of extra power cheaper. So 200 amp versus 160 amp charging. So it will take you 1.4 hours to charge fully versus 1.75 hours. So it's just so much extra power that can actually go into the battery. So we have 160% overload for 200 milliseconds in off-grid mode. In other words, this is when the backup port is on. And then there's another, I'm not sure if the slide is in here. You have to give me, I don't normally, this is Jason's job. But there's 4 different distinct power ratings against time for inrush and extra power. So it supports generating across a wide range. So in other words, just here in a nutshell, we can work with any generator in this generator function, right? All of them. And again, it allows us to do that because of the functionality in the setting of the power, the setting of everything. And it allows you that flexibility to specify power. Okay, we were talking about this, different batteries. I'm not going to spend too much with this. This is a graphical. So again, you can see different watt hours, but we want the voltage always to try and stay the same, even between different brands, on the same inverter on 2 different BMSs. And then also the configuration can change between 3 inverters in parallel. Obviously, within high voltage systems, each inverter has its own battery bank, and that can also change in terms of capacity and everything else. Okay, so we have the LCD spoke is now 50% larger. Okay, I think we've covered most of these. So in the interim, first off on these ones, the initial launch, tongue's twisting, there will be 6 of these units in parallel. So now it was allowed to go up to a system of 750 kilowatt, and then later on, with the addition of an STS, you can go to 1.25 megawatts, in other words, 10 of these in parallel. Okay, and then I think the battery capacity grows to about 6.5 megawatt hours in depth when you're at 1.25 megawatts. Okay. These things. I'm just going to skip over the stuff that we've already discussed. This is a really long presentation. Just on the side here where the connections go. So the generator and the grid connection is actually in the side cover there. So that also allows you now to run in quite bigger aluminium cables over distance. There's something I want to talk about just when it comes to cabling and the home runs on cabling. Everybody has done C&I systems. I'll just take it, right? Even grid tie ones. One of the biggest things we have to deal with every day is over voltage alarms on the PV systems, right? Because the voltage of the system just creeps up. It's 253, and the inverter says, listen, you're on alarm 1, you've got 40 seconds to correct yourself, or otherwise I must disconnect. Right? The biggest problem with that is the size of the cable. Home run is long, size of the cable is too thin, and for the inverter to get the power over there, or that amount of current to that point, the only way to do it is to increase the voltage. Okay, and then the guy says, oops, trap inverter keeps going into over voltage. It's not that. Right? It's the cable is too small. Okay, we've seen that like time and time again. You can actually see it very clear. We've got a 50 kilowatt inverter, and once it gets to like 30 kilowatt, the guy starts getting over voltage alarms. Okay, below that it works fine. But as the power increases, all of a sudden you start getting alarms. It's a dead giveaway for it. Okay, so what we generally recommend to the guys is just, this is a little bit way off the topic, but it will help a lot. So in your home run, if you calculate, I mean, you don't even have to do the math these days. You know, you've got online calculators, like a gazillion of them. So you just put in the length, the current, all that, and the distance that you need, and the voltage that you're going to carry it. It will give you a voltage drop percentage. All I'm asking you is do that voltage drop, but keep the voltage drop under 1%. Not 5% or 8% like in the house, people don't care. PV systems don't like high voltage drops. I had a customer some time ago, it's not a big system, 40 kilowatt, but he was running, the home run was like 400 meters. And he did it with 2 different cables. So half of that was with 50 mil aluminium and half of that was 50 mil copper. At the end of the day, the voltage drop was something like 29 volts. With already increased grid voltage, so he was like just sitting at plus 253 volts. The inverter just wouldn't switch on. Okay. Eventually, when they changed it to a shorter run and the cable size properly, and the inverter worked fine, no problem. But it was also one of those guys, my electrician has told me. Electrician must just do the math. So it's just something that just came to my mind. We get a lot of that. So the home run, and especially now you're changing the aluminium cable, what happens with aluminium? This is copper. Size. The size immediately needs to go up. Okay? And then also if you're using aluminium, on the lugs, bimetallic lugs. Copper aluminium lugs. Okay? Because we see also a lot of that causing a lot of problems. Okay, so we come to changeover times. So up to 6 inverters in parallel, we have a changeover time to the backup port completely in less than 10 milliseconds. Okay, we do about 4 milliseconds on a residential product. So 10 milliseconds up to 6 inverters. After that, the STS will allow you up to 10 inverters, but pretty much UPS switchover function. Okay, it's really quick. Okay, we already mentioned 10 units in parallel. Data sheet, we were talking about some of the stuff earlier. So battery voltage up to 950 volts DC on a battery from 300 volts. Right, 300 volts the minimum. And then 200 amps total, 100 plus 100. There's 2 charge and discharge ports, CAN or RS485. The capacity you can see at the top is 250 kilowatt, and you can see the 10 MPPTs rated at 42 amps each, which basically comes down to 21 amps per string. And what's the other significant thing you see on the data sheet? At the top there, starter voltage of the inverter from PV. Okay? A mere 150 volts, which is very low. Okay? So you're going to start up really quick. On a single-phase inverter, something like 90 volts. We've actually tested that with two 450-watt modules, and it will start, just with 2 modules. Okay, and then we both 10 MPPTs, 20 strings per MPPT. I'm not going to go through the whole data sheet, but it's pretty impressive. So from the grid, or the grid side, AC output is 120. When we were talking about, you can't take 250 kilowatt and send it back to the grid. Okay, so 125 kilowatt though, you can. So we were talking about what is the 100%, 41.66 kilowatt per phase. Come on. Oh. Obviously, we're not going to get into like the monitoring system. That's going to take another few hours. But we have a fully integrated monitoring system. So on a monitoring system, you have access to every single function with this inverter as an installer. Okay. End users and the people else, they've got a different set of access. So they can do a little bit less than what you can. But from here, you can basically monitor everything. And we have another little function. How many people have installed CTs the wrong way around? And realize it later? Okay. I know a lot of people have done it. At one stage, I did it myself. The wonderful thing is we can actually change the direction through the monitoring platform now. Okay, so if you've installed the system and it was low PV production at the time, you say, no, CT is the right way. Yes. Let's go, beer time. And that night or the next day, it's like, why is the system exporting? Yeah. CT. Okay. So it's very important, but there's so many features in there. All these settings, all the time chart settings, everything, you can set all of those remotely. Okay, so there's 2 QR codes. This will be made available. There will be a QR code at the back. You can scan it, you'll get the whole presentation, right? And there's a whole bunch of other ones, and we've got SOPs. I'll explain all of those now later. So from our technical support perspective, these 2 codes, they will be in the presentation that you will have access to. The contact details within there. We've got a national call line, we've got a service line via email, and with a lot of the installers and stuff, we already have WhatsApp groups going and whatever. It's like a gazillion groups, tough to keep track of them at sometimes. And then presentation slides and documents, generally for the general product range, is all in there. And then at the end here, we have a small questionnaire that we would like, once you get your hands on the presentation, if you can just complete a storage market research questionnaire, and that is basically just asking you a few questions about residential and industrial energy storage market. Okay? So it's really just for us, for market research, because every market is different, and the more information we get from the market, the better we can service that market, and the better products we can actually develop for that market. Okay? Just in terms of all of this, obviously this is a brand new product, but for every one of the other products, if you ever have a problem with setting anything up, setting the generator up, doing time of use, any one of these, self-use, we have a complete set of SOPs for every product, okay, and every function. So if you want to set the generator on a smart board, there's an SOP already calculated for that. Already done. It's a set of documents. All you have to do is follow from point 1 to point 20. There's screenshots of the app, what you need to switch on, what the values need to be, where you set them. So all of that, we've done that work for you. Okay, which will be the same. Once we get our hands through this thing, it will be the same set of documents will exist for this as well. Thank you very much, everyone.